Hello, in this video we will show briefly how to implement a classification module using supportvectormachine algorithm in Python. A supportvectormachine, also called SVM, is a kind of optimization method to maximize the margin between two classes. So if you look at this figure, this is the margin, and along both sides of this margin, they are like a boundary hyperplane with the each classes. And this also called vector, so support vector. And in supportvectormachine, try to maximize this gap between these two classes. But the question is what's the cost if there is wrong or the error or the point at the wrong side of the margin? So for example, if we set the cost is very high, so the result may look like this kind of support vectors, because if we have wrong side points occurring, so it will be very high cost. But if the cost is not very high for the parameter regularization, then it's possible getting the result, this kind of results. So this is the point at the wrong side, because it's not very high cost if we make projection wrong, and the gap will be very wide. So this is the called bias variance trade-off, because in this example we set a very high cost and there is any wrong classification point. But this only applies to this data set, may not apply good for new data. But on the other side, so this is may have overfitting, but this kind of model may get underfitting because the bias is very clear, because they are wrong classification. So it's a trade-off between the bias and the variance, or between the overfitting and underfitting. So next we will show how to implement such a model in Python for support vector machine. So if you are interested in the code, maybe you can download these files from this link and try it later. So we first load all modules. So set the working directory. So load all the packages. Just skip this part. And we first load the Iris dataset. And we set the two features of this dataset and this target for the label. And we set the training data and the test data using train test split function, and with 30% of the data for the test and with the stratifying Y. Next we will show the original all the data and the test and training data for 3 classes. They look very fine. Next, we standardize the data for training and test, so they have same scale, normalized with 0 mean and standard deviation 1. So next, we will skip those parts for the perception, because this is done in other video. But we will create a function called plot decision region, because in this function, we will plot a map map with a very dense point between two features, and each point will be projected with the trained module. Then each class will have different colors for the region. Then we plot the real observed points on this map to check if there are wrong classification points. So we just run this and create this function. Then we will use this function after the model is trained. So next, training a perception model will be skipped. And the logistic regression also skipped. Sorry, but maybe we will check. Anyway, we use this data. So we just create this X combined and STD and X combined data. Then skip the model part for logistic and perception. Skipped. Then we run the data part for the 0 and 1 classification. So logistic part also all skipped. Regularization also skipped. Then we come to the maximum margin classification with the support vector machines. This part. So here we will use SVC function to create a module using the kernel linear and C. We just use 1.0, but of course you can change with different values and run several times for the module and the random state 1. It is done. Then we can use this model to train the training data. It is done. Then we can use plot decision region with alt X combined standard data and Y combined label. Then classification, use this model, train the model, and we also mark the points for the last 50 point observations as test data. So we will run. So you can see this is support vector machine's plot decision region. 3 colors represent millions of points will be projected with 3 classes labels from the trained module. So, and these points are the real observed points. We just check if there are points on the wrong side. This is correct classified. This is also classified in the same color region, right? But you can zoom this map to see if it is correct and change the regularization parameter C here for the cost. So this is the very basics of the support vector machine training in Python. Thanks for watching.